Hey, I'm back. This is part two. I just wanted to make sure that the video didn't get too long, but I also wanted to make sure you guys got the examples. So I put the examples in this part two video. So refer to the first video for the information needed to do these examples. So the first example is determine the exact values of the primary trigonometric ratios for 135 degrees. Now, the one thing you're going to do is think about where does this angle fit in our coordinate plane. So I always kind of first draw it because I want to see where it is. This is 0 to 90, so 135 I know is here. So that's 135 degrees. But what we actually want to know is what is our reference angle. So I always do, especially in this one, because here's 180. We'll do 180 minus 135. And 180 minus 135 is 45 degrees. So we're thinking about 45 degrees in this case. And the other thing I'm trying to remember is also my cast rule. So CAS, this is S. So I already know that for the angle of 135, it is in quadrant 2, so sine is going to be positive, cos is going to be negative, and tan is going to be negative. So let's just write that down. Sine is going to be positive, cos is going to be negative, and tan is going to be negative. So I know that just from the cast rule and which quadrant I am in. The next thing I'm thinking about is this is a 45. Our reference is 45 degrees. So I'm going to think about our triangle, which has 45 degrees, being 1, 1, root 2, which I gave you in the previous video. Again, I just know it. I have it memorized. The more you do trigonometry, guys, you'll have it memorized too. But this is what we're going to use to find the exact values. We're going to use this triangle. Sorry. So here's what we're going to do. If we want to know the exact primary trigonometric ratios for 135, sine 135, it's the same as the 45 degree because that's our reference angle. We just have to pay attention to our signs, whether it's going to be positive or negative. So cos 135, tan 135. So if you want, the nice thing about knowing that already is this one's going to have a negative and this one's going to have a negative. And then we'll just use SOHCAHTOA and our primary trig ratios that we did for 45 on the previous page. So sine was 1 over root 2. And it's positive. Cos was 1 over root 2, but in this case, because it's in that quadrant, it's negative. So negative 1 over root 2. And the tan was 1 over 1, which just gave us 1. But in this case, because we're in that quadrant, it is a negative 1. And that's honestly, guys, that is just how you do it. You look at your reference angle, find out what quadrant it's in, find out the ratios from the special angles, triangles that I gave you first, and then set it all up. It is that simple, but it is a lot of little things to remember. So that's why I have lots of videos and stuff. Let's move to the second example because I'm going to show you guys how we can use a special angle to solve some primary trigonometric ratios. Okay, so here's an example. A 3-meter long brace is placed against a wall. So the bottom of the brace makes an angle of 60 degrees with the ground. Ooh, 60 degrees. Special. So you guys will start to see these anytime it's a 45, 30, or 60, or one of those other angles that have that as a reference angle. You're going to be like, ooh, special triangles. We're going to draw a diagram to represent this situation, and we're going to figure out how far up the wall is the top of the brace. So let's start with the diagram. We have a wall, and it's going to have a brace placed against it so that the bottom of the brace is 60 degrees. Now we're assuming that the wall is built straight and that it has a right angle. It's a very big assumption we make with a lot of buildings, that they're built straight and they have 90-degree angles, which means this other one is 30 degrees. Right away, I can think about my special triangle and be like, well, the ratio is 1 to root 3. Again, because I have it memorized, feel free to have that as a reference to you. Now, the other thing, it gave us a couple of different things. It's a 3-meter long brace. So this distance is 3 meters. Makes 60 degree with the ground. How far up the wall is the top of the brace? So we're going to have to find that out. Okay, so let's set it up. We're looking for the wall side of our 60 degree. That is our opposite. And we know that we have our hypotenuse. So we have our hypotenuse, and we need our opposite. So we're going to use sine, because sine is opposite over hypotenuse. Now, we also know, because our angle is 60, from above and from the rest of the note, that sine 60, the ratio is root 3 over 2. So in this case, we kind of sometimes don't need to use the calculator if you're good with fractions. And because we want to find an exact value for this, we want to know exactly how far up the wall we're going to go. So what you're going to do is set it up. Sine 60 is our opposite, which we don't know, over our hypotenuse, which is 3. But I'm going to replace the sine 60 with our root 3 over 2. So root 3 over 2 is equal to x over 3. So now all we have to do is do some cross multiplication. I'm basically just going to take this 3 and move it up to the other side so that it becomes 3 root 3 over 2 equals x. Now, this is our exact value. So if the question's asking you for the exact height of it, you would say it's 3 root 3 divided by 2. If you just want an approximate value, then you would just use your calculator for it. So approximate value. So this is our exact, which some mathematicians like, but we can also do, I'm just going to calculate divided by 2, which is 2.598 or 2.6. 2.6 meters up the wall, which makes sense because our hypotenuse was 3, so it has to be less. Exact value, approximate value, they are the same thing. It's just that if you want the exact value, using the special angles really helps with that. And that's how you do one of the examples. You guys got some a couple little word problems in the practice, so that this example will help you when you go to do those. And that's it. I know it's a big lesson for today, guys, but I think you can do it. Just make sure you watch the videos and have these special angles and special triangles for your reference. If you have any questions, please shoot me a message, okay? Because this lesson kind of sets up the rest of the lessons for the week, and I don't want you to be feel like you're lost. And if everybody tells me they're lost, I will make sure that we're not lost. Okay, so have fun, guys. Shoot me a message if you need to, and I'll talk to you guys later.